Hey all, just going through the answers to that practice SAC that was sent out at the end of last week. Sorry if the formatting, that original one I sent, was all over the place. This should make more sense, the new one I sent as well. So I'll just go through each of these answers for you. All right, you don't have to listen to the whole thing. If you want, just skip through to the questions that you need as well. Okay, but section A, multiple choice. Okay, a reminder that SAC's on Monday now too, so fill in that Google form about coming in. If you want to come in and do some stuff at school, okay, before Monday, that's fine as well. I'll be in most days as well, till the end of the week, so that's fine. All right, section A, the multiple choice, question 1. So we've got the matrix there, okay, and it is equal to. Okay, so if you look at each of the answers for A, B, C, D, and E, it's got that 7 out the front. Okay, so it's like a scalar matrix. Essentially, what we've got to do is just divide each of these numbers, okay, in this matrix by 7 to get the answer. So if we divide each of those numbers by 7, okay, we should get E, okay, because 21 divided by 7 is 3, 7 divided by 7 is 1, all right, 35 divided by 7 is 5, sorry. Cool, so a nice one to start with. Okay, question 2. Amy, Beck, Kai, and Daniel stand in a row in this order. Which of the following permutation matrices would change their order to Kai, Amy, Daniel, and Beck after one move? Okay, so I'll just highlight that. It's only multiplying once. Okay, one of these permutation matrices. So what a permutation matrix is, guys, it would just change the order or positioning of a matrix. Okay, so what I'll do is I'll put our original members in. So we've got Amy, Beck, Kai, and Daniel. Okay, and what we want it to become is Kai, Amy, Daniel, and Beck. Okay, so what we've got to do is we've got to multiply by one of the permutation matrices, A, B, C, D, E. Okay, and with that, we've just got to make sure we do it in the right order. Okay, so this is a 4 by 1 matrix. Okay, and all of the other matrices are 4 by 4. Okay, so for this to work, we have to do the permutation matrix first. Okay, so what you do on your calculator is just do... I'll just move this. Just do each of these matrices one at a time. Okay, until you get the answer, and you times it by this guy. Okay, making sure that permutation matrix is first. Okay, until you get it to look like... Oh, sorry, it wasn't that guy. It was our original one. Let me just get rid of that. Times it by... I'm all over the place. Times it by this guy. All right, and you'll get it into that order that I just rubbed out. I don't know why I rubbed that out. Anyway, if you're doing one at a time, it'll be Amy that gets it to that order that you want, the Kai, Amy, Daniel, and Beck. So it'll come back to quickly do it. Kai, Amy, Daniel, and Beck. Sweet. All right, if you do that permutation matrix at the end, as in you multiply it after this column matrix, okay, it won't work. Cool. All right, question 3. The 4 matrix equations below each represent a system of simultaneous linear equations. Okay, the number of these systems of simultaneous linear equations, which have a unique solution is... Okay, so if you ever see like unique solution, okay, it's on your summary sheet, that double-sided summary sheet, and it's about the determinant. Okay, so essentially it's saying if the determinant, okay, which is A times D minus B times C, if it doesn't equal 0, okay, it's going to have a solution. Okay, if it equals 0, then there's no solution. So what we're going to do is we're going to do each of these matrices, and we're going to do the determinant for each to find out how many solutions we have. So the first one, I'll just highlight. We're going to do this one. So you do all the numbers just in the 2 by 2 matrices. Okay, so our A is 2. Our D is the bottom right number, the -1. Minus our B is 1. Okay, and our C is -2. All right, so 2 times -1 is -2. All right, -1 times -2 is +2. Okay, so that equals 0. All right, so that one doesn't have a solution. Okay, I'll just do each of these one at a time. So now we're on to this guy. Okay, so applying this rule again, it's going to be 6 times 1 minus 3 times 2. All right, which equals 6 times 1 is 6, minus 3 times 2 is 6. Okay, so 6 take 6 is 0. Okay, so we haven't got a solution so far. All right, we're on to this third one now. I'll just point to it. Okay, so we've got 3 times 4 minus 6 times 2. Okay, I'm doing these in my head, but you can just go straight ahead in the calculator and put that in if you want. But 3 times 4 is 12, minus 6 times 2 is 12. Okay, so that one's 0. All right, and the last one, move across, okay, is 1 times 1 minus, so we're doing that one, minus 1 times 1. Okay, 1 times 1 is 1, minus 1 times 1 is 1. All right, so that all equals 0. Okay, so none of these matrices or linear equations, okay, will have a solution. So the answer's A. Cool, moving on. Question 4. Given that matrix P is a 2 by 2 matrix, and matrix Q is a 3 by 2 matrix, which of the following matrix expressions is defined? All right, so there's a number of ways you could do this, guys. If you wanted, one way you could do it is you could actually make a random 2 by 2 matrix as P. Okay, put in whatever numbers you wanted. Okay, and then you could make a random 3 by 2 matrix for Q. Again, putting in whatever numbers you wanted. Okay, define them as P and Q, and you could just do each of these one at a time. Okay, so that's a really quick way. All right, if you do them, like the ones that won't work or the ones that aren't defined will come up with like an error. Okay, the one that'll work, if you don't want to do them like that way, the other way is just doing them sort of by hand. So if I look at A, P's a 2 by 2, okay, Q's a 3 by 2. Okay, these middle numbers don't match up. All right, so A won't work. Okay, if we look at B, do the inverse of Q. Okay, you can only do the inverse or square matrices or cube matrices or whatever if they're square matrices. Because Q's a 3 by 2, it won't work. All right, so that's wrong as well. We'll just cross out the wrong ones. Okay, for C, what we're doing is 2 times P, so you're just doubling all the numbers in P, so that's fine. But then you're going to add it to Q. Okay, so P and Q, they don't have the same order. Okay, you can only add and subtract matrices with the same order, all right? So C won't work. Okay, D won't work because you can't square like Q's a 3 by 2 matrix, so I won't let you square it. All right, so E is going to be the one that works. Again, I'm just showing you 2 ways of doing it, but so I'll write it below. Q's a 3 by 2. Okay, P's a 2 by 2. Okay, and we're going to minus Q, which is a 3 by 2. Okay, just looking at when you multiply Q and P, okay, these two middle numbers match up, so it'll work. Okay, the resultant will be the outside. So what we're going to have is a 3 by 2 minus the 3 by 2. Okay, so that'll work. Again, if you don't like it that way, just definitely do it this way. Put in random matrices, define them, do them one at a time. That's fine. All right, question 5. A study of kangaroo population in a wildlife park has shown that they regularly move between 3 locations. Okay, the bushland, the paddocks, and the shrubbery. Let AM be the state matrix that shows the population of the kangaroos, okay, in each location n months after the study began. The expected population of the kangaroos in each location can be determined by the matrix recurrence rule. Okay, and we've got the rule there. So what we've been given, guys, we've been given the transition matrix, we've been given the B, okay, and we've also been told A3 here, so the 3rd month. The number of kangaroos in each location in the 3rd month. Okay, what the question wants. Okay, the number of kangaroos in the shrubbery location, okay, 2 months after the study began, as found in the matrix A2. Okay, so I'm just highlighting that. We need to find A2. So this is that question I was saying I haven't taught you guys yet, so I was hoping to teach you it in person. There's also a mistake in the question as well. It won't give you one of the answers. But I'll leave it as the 20, and where it is, it's in this B, but I'll leave it as it is just for the moment to show you guys. Okay, but each of those numbers in that matrix is supposed to be 50. But we'll just go on with what we've got. So what we've got, guys, we're going to use this recurrence relation, okay, to help find A2. Okay, so essentially, if we look at A3, that's the month after. Okay, this recurrence relation, it'll always just find the next month. Okay, so A3 is, the one after A2, so that'll be the one out the front. Okay, and what we're using as our transition matrix times the one before, okay, which in this case is our A2, and then you're minusing that B. All right, so what we've got here, guys, is we know the information, or we've got the matrix, the information for A3, our transition matrix, and B. Okay, and what we've got to find is that A2 matrix, or the A2 matrix. Okay, so what we've got to do is rearrange this equation. Okay, and you can just remember this format, or how you do it to find the one before. But essentially what you do is you add the B matrix. Okay, so you'll have, and you don't have to remember this order, but you'll add that and that'll leave you with just T times A2. Okay, and we're just trying to get rid of everything on the same side as that A2. So we're going to get rid of this transition matrix. All right, if you get it to the other side, it's using the inverse. Okay, so essentially your A2, I'm just writing it around the other way, is going to be the inverse of T. All right, and then you've got this A3 plus B. Now what you just got to make sure is that this is in brackets, okay, because you want that addition first. Okay, so you can remember, if you don't want to remember how to do it, that's fine. But if you're ever trying to find the one before, okay, it essentially will just follow this format. Okay, so what we've got to do is the inverse of T times, include the brackets A3, which we've got, plus B, which we've got in brackets. Okay, and that'll give us, I'll just quickly do it. Okay, so that'll get us, you'll get 526, and it'll be in decimals, it's like 0.67. Okay, 376.67. Okay, and 421.67. Okay, so I'm just pausing the video while I'm doing the working. So I'm not doing it that quick, but so you get that, and remembering just that order, that's the bushland, the P is the paddocks, and S is the shrubbery. Okay, so what we've got, the number of kangaroos in the shrubbery, okay, after the 2nd month is this value here. Now you'll see that's none of our answers, okay, and that's because these numbers are supposed to be 50, okay, so if you want to use it as 50, you'll get one of the answers. I forget which one it is, but essentially 421 kangaroos will be in the shrubbery, okay, in the 2nd month. All right, so as I said, that's, something like just this little one I haven't taught, well, it's going backwards in the recurrence relation. Okay, so I can send you another question on going backwards as well. All right, but yeah, it was impossible to get with the 25s, so that's fine. Question 6. Okay, we've got the matrix equation. All right, it has the solution. All right, so this one's quite an easy one. Okay, if I just label this matrix A, this matrix B, and this matrix C, essentially what this is, looks like this at the moment, just with the notation. Okay, what we're trying to do is we're trying to find the values for X, Y, and Z. So we want to get B by itself, so we'll do the inverse of this matrix up here. Okay, always put it first, times C. Okay, and that'll get us our answer. Okay, so I'll quickly do that. Okay, and what that gets us, so that's going to equal 5, 3, and -2. Okay, so a common mistake there, guys, just make sure you include that to the power of -1 as well. All right, so the answer is B. Okay, question 7. Okay, a shoe shop takes delivery of a large consignment of shoes. Okay, the number of containers and the number of pairs of shoes in each container is shown in the table below. Okay, in each of the categories of men's, women's, and children's shoes. Okay, so what this table's got for us, it's got the number of containers, okay, and it's got the number of shoes that are in each container for men's, women's, and children's. Okay, the question though, the total number of pairs of shoes delivered to the shoe shop can be calculated using the matrix product. Okay, and we've got all these different ones. All right, I think the best way of doing this question is just working out the total number of shoes that'll go to the shoe shop in total. Okay, so if we look just in the table here, we've got 3 containers of men's shoes. Okay, and each of those containers have 54 shoes. Okay, so in total, we can have 3 containers of 54 going to the shoe shop. Okay, and what we're doing here is we're just working out the total number of shoes that are going to go to the shoe shop first. Plus, we've got 7 containers, and in each of those containers is 68. Plus this column here, we've got the 4 containers, okay, with 72 shoes in total. Okay, so we're not really working out the answer, but what this will do, this will help us just work out, which of these, like A, B, C, D, or E, will give us the right answer. So I'm just going to quickly do that. 3 times 54. All right, and the total number of shoes I get is 926. Okay, so if we think about it, guys, the total number, it's going to be a 1-by-1 matrix. So what we're looking for is pretty much which of these products will give like this just 926. Okay, so what you could do, it's tedious, but you go through each one and just work out which one's going to give you this 926. Okay, a little hint I'll give you. Okay, if this matrix here is a 1-by-1 matrix, essentially the very first number of our product should be a 1. Okay, and the very last number of our product should be a 1. Okay, so what I mean by that is if we just look at A, okay, this matrix is a 1-by-3, so that's sweet. Okay, and I'll just go through the order of each of these matrices. So this is a 3-by-1, okay, and this is a 3-by-3. What I'm saying is essentially this very first number and this very last number should be a 1 and a 1. Okay, so this one won't work anyway because when we're multiplying across here, this 1 and 3 don't match up. But the only other one that'll have the 1 at the start and the 1 at the end is D. Okay, so this is a 1-by-3, this is a 3-by-3, and this is a 3-by-1. Okay, so these 1s are on the outside. Okay, and we'll know that these work because when you multiply across, these 3s match up, these 3s match up, so on. Okay, so the answer will be D. That's the one that'll give you that 926. All right, so, yep. All right, question 8. I'll just zoom out a little bit. All right, the price in dollars of 3 different size televisions for 3 different brands at a major retail store is shown in the table below. Okay, so we've got another table. We've got 3 different television sizes. Okay, and then the cost of each of those television sizes for 3 different brands, A, B, and C. Okay, the retailer is about to discount brand A products by 10%, brand B products by 25%, and brand C products by 15%. Okay, which of the following matrix equations would give the discounted price in dollars of the 3 different sizes TVs for the 3 different brands? Okay, so if we think about it, I'll just highlight it. What we want to do is we want to apply these discounts. So A is discounting by 10%. I'll just include that discount. B is by 25%. Okay, and C is by 15%. Okay, so what I'll do is I'll just write that down. So A is going to be, if you're doing a discount of 10%, that means you're timesing by 0.9. Okay, B, if you're discounting by 25%, that means it's going to be 0.75. Sorry, I've written a 2 there. 0.75. Okay, and a discount for C is 15%. So that means you're timesing by 0.85. All right, so what you do is you're looking for these numbers, and essentially, guys, if you're trying to do it for each, how do I best explain this? If you're trying to do it for each television, okay, if this matrix up here, I'll just make this a matrix. All right, this is a 3 by 3 matrix. Okay, what we want to do is we want, as our result, I'll do it over here, is another 3 by 3 matrix, because we want these discounted prices for each of these values. Okay, so if I just put this as like a 3 by 1, so I'm just showing you up here, it'll work, okay, but we're going to get a 3 by 1 as our resultant. Okay, so for this to be a 3 by 3, this has to be like a 3 by 3 matrix. So you've probably seen questions like this before, but essentially the decimals are going to go down the diagonal, okay, and the rest are going to be zeros. All right, again, like you don't have to know this. If you want to just do each one of them one at a time, okay, it's going to work for you, and you know it's a 3 by 3 and a 3 by 3. Okay, the 1, if we look through them, so A is going to be wrong, B is going to be wrong because it's not the right decimals in that second matrix. Okay, C is going to be wrong because it's not a 3 by 3 and a 3 by 3. Okay, so it's either going to be D or E. All right, so again, if you want to just put both of those matrices, okay, in your calculator and work out which one will do the right discounts, that's fine. Okay, but it should be E. All right, that'll apply the discounts. Yep. Okay, question 9. So for T, we've got the matrix there, and for the initial state matrix, the steady state is. Okay, so guys, if you're ever trying to find the steady state, what you do is you do your T to the power of a massive number times your initial state. Okay, and then you'll get a matrix. And then to check whether it's a steady state, just do 1 extra. So it's the power of 1 extra. Okay, and if the numbers don't change, that means it's your steady state. Okay, so I'll quickly just do this first one. Okay, and what I get is this answer, 69, 138, and 23. Okay, and then what I'll do is I'll quickly just change the power of that first one to 101. Okay, if it's the same, which it is, okay, this is the same numbers. Okay, we know that that's our steady state. All right, so the answer will be B. Cool. All right, just zooming out. Question 10, a large city accounting firm moves offices Okay, the staff can either drive to this office or use public transport. A transition matrix that predicts the way staff will change their preferences each day as to how they get to the office is given by. Okay, so what we've got here is we've got this transition matrix just to say how people will be traveling to work each day. Okay, over time, if this predicted pattern were to continue, the number of staff who would drive to the office would. Okay, so there's two ways of doing this, or a number of ways of doing it, but what you could do is you could start with an initial state, okay, and times your transition by this, okay, to just work out how people move over time. Okay, and you'd want to do that because it says over time, that means in the long period pretty much, so your steady state. So do it like t to the 100 again, times this guy, and just see what the numbers equate to. Okay, so I might actually quickly do this. Okay, and what I pretty much get is that this is really close to 0. Okay, and this is pretty much 200. Okay, so all the people will go from driving to, what's the other thing? Public transport. Okay, so essentially the number of staff who would drive to the office, okay, would reduce to 0. All right, the other way you can work this out is just by looking at the transition matrix up here. Okay, so what you can see is that of the people who are in public transport, they're going to stay in public transport for the next day. Okay, and each day the drivers, 10% of those will go to public transport. Okay, so if they're contributing 10% each day, okay, and all the ones who are in public transport will stay, okay, if you keep doing that each day, the drivers will get lower and lower and lower and lower. Okay, in public transport, those guys will stay. All right, so that's another way of looking at it as well. It's just looking at that transition matrix to see the numbers as well. Okay, question 11 and 12. Okay, residents of a large town have a choice of 2 power companies, okay, Green World or Energy World. In an effort to attract more customers, both companies start a discounting campaign. Okay, the number of customers each company has in this town at the start of the campaign is shown in the table below. Okay, one of the energy companies predict that during the campaign, customers could change their energy company each month, okay, according to the transition diagram. Cool, so we've got pretty much the initial state. Okay, and we can use this transition diagram to make the matrix as well, the transition matrix. Okay, so question 11, the number of residents who are predicted to remain with the same energy company 1 month after the discount campaign begins is... All right, so the key word in that question, what it wants to know the number of residents who will remain, okay, in the same energy company, okay, just for 1 month. Okay, so this transition diagram, I'll point to it again, it just shows the movement for each month. Okay, if Greenworld originally had this 2,430, we can see that of this 2,430, okay, 88% will stay in Greenworld. Okay, so what we'll do is we'll times that by 0.88. Okay, but the question asks just who will remain with the same energy company. So what we've also got to do is find out the Energy World people as well. How many of those will stay? Okay, so with the Energy World, we've got 1810. Okay, and we can see, I'll just highlight it, that 76% will stay in Energy World. Okay, so you times that by 0.76. Okay, and that'll give us, the number of people are just going to remain in the company. All right, so I'll quickly do that. Okay, and that'll equal 3,514. Cool, so that answers E. All right, question 12. 6 months after the discount campaign begins, the number of customers that Energy World has is closest to. Okay, so if you're a highlighter person, we're looking after 6 months. Okay, and we're looking for Energy World. Okay, so like I said before, the information above we can use to make matrices. Okay, so initial state one is this 2430 and 1810. Okay, and I'll just label that as G and E. Sorry, my writing's not neat. Okay, and then using that transition diagram, we can make a transition matrix, so a 2x2 one. And I'll start with Green World. This is Green World, Energy World. Okay, Green World, Energy World, just where they're going from. And I'll just put monthly or capital M. And this is, run out of room, but this is 2 monthly. Okay, so we're just going to use those percentages in the transition diagram. Okay, so 88% of the Green World customers will stay in Green World. Okay, and then we've got the 12% from Green World to Energy World. Okay, which is that number up here. Okay, these columns should always add to 100% or 1 as well. So if you didn't have this number, you'd know it was 12. Okay, with Energy World, we know that 76% of the customers that are in Energy World will stay in Energy World the next month. Okay, so this one's 0.76. Okay, and then the ones who are moving from Energy World to Green World is this 24%. Okay, again, it should add to 1 anyway, but that's 0.24 there. Cool. All right, so we're just trying to find after 6 months. So essentially we're going to find S6. Okay, so we're going to do a transition matrix. Okay, if you don't want to do them one at a time, just to the power of 6 times the initial state. All right, and we'll just see what that gets us. All right, so what I've got is pretty much 2,000. It's 2,700. I'll get rid of that. 2,700, 9.4. Okay, and I've got 1,440.6. Okay, so what it wants to know is the number of people in Energy World. So this one was Green World, this one's Energy World. Okay, so it's going to be closest to A. Okay, if 1440 was an answer, I'd probably put that one because like they're people, something tangible. So you'd round down, but yep, it's A. All right. Question 13. The families of students attending a large secondary school can elect to receive the weekly school newsletter in hard copy or email form. Okay, in week 1, equal numbers of hard copy and email versions of the newsletter, okay, were sent to families. Okay, in subsequent weeks, this changed according to the transition matrix. Okay, so I'll just highlight that. In week 1, okay, we had equal numbers that got hard copy and email versions of the newsletter. Okay, and we've got our transition matrix below. Not sure why there's E's and U's. These, whatever these are. All right, if this pattern were to continue, it would be true to say that the number of email versions of the newsletter sent to families each week will, okay, and then each of those answers wants to know with decreasing or increasing, so on over the long term. Okay, so what you could do, guys, is you could use this transition matrix, okay, because you're trying to find over the long term, like to the power of 100, okay, and times your initial state. Now, if we had equal numbers in hard copy and email versions, let's just say we had 100 in each, we could just see what happens, okay, to the email people. So this one's going to be hard copy. This one's email. So we're going to see what happens, all right, just to like this bottom number when we do it. Okay, so I'll quickly do that. All right, and what I essentially get is, it was about like all the people have left hard copy, okay, and everyone's gone to email. All right, so yeah, the email people, they'll double over the long term. Okay, so the answer will be E. Okay, and another way you could have looked or found that out is just looking at the transition matrix. Okay, it's similar to the question above, okay, where we've got 100% of the people who are in email will stay in email. Okay, and then each week we've got this contribution from the hard copy people going to email. So eventually everyone's just going to end up in the email section as well. All right. Okay, question 14. Okay, each night 300 holiday makers at a senior holiday resort, okay, participate in one of three activities: dancing, lawn bowls, or bingo. Okay, the activity that a holiday maker participates in each night changes according to the transition matrix below. Okay, so we've got our transition matrix here. Okay, on the first night, an equal number of holiday makers participate in each activity. Okay, so some key information there. We've got an equal number in each activity. Which of the following statements is not true? Okay, and then it just goes through each of them. One way you could do this, okay, again, like the question above, is you could do your transition matrix. Okay, because each of these questions is asking for the second night or the next night, a lot of them. What you'd do is you'd times it by, okay, that initial state matrix. Now, we don't actually know what the initial state matrix is. We don't know the number of people in each activity, but it did say that there's an equal number in each activity. So what you could do is just use whatever numbers you wanted, okay, as long as they're equal. But I might just start with 100, 100, and 100, okay, because they're nice numbers. Oh, and we had 300 people in total, so it's got to be that actually. So I'll quickly do that and just see how people transition. All right, and what I get on the second night, okay, we've got 100 people, 130 people dancing, 70 people doing lawn bowls, and 100 people still in bingo. Okay, so I'll just list that: dancing, lawn bowls, bingo. Okay, so I reckon this question's probably the hardest one on the SAC because it's just, these questions which make you eliminate ones, like the not trues, which one's true, are just tedious. You've got to go through each one, but that's fine. Okay, so we're going to go through each statement, find which one's not true. Okay, so 40% of the holiday makers participate in the same activity on the second night. Okay, so what we've got to do is we've got to look at each of the people in the first night. So we had 100 people in each activity, and just work out whether 40% will stay, like in total 40% will stay in that activity. Okay, so looking at this transition matrix, okay, of the dancers, okay, 60% will stay in dancing the next night. Okay, of the people doing lawn bowls, 10% will stay in lawn bowls. Okay, and of the bingo people, all right, 50% will do bingo. Okay, so we want to work out whether that will aggregate to be 40%. Okay, so what you do is we had 100 people, so I'm just doing this one here, 100 people in dancing, okay, and 60% will stay. Okay, we also had 100 people in lawn bowls, okay, and 10% will stay. Okay, and we had 50% in bingo. Okay, and we had 100 people in bingo and 50% will stay. Okay, so this will give us the total number of people that stayed in their activity for the next night. Okay, and that equals 120. Okay, so what that question's asking is 40% of the holiday makers participated in the same activity on the second night. Okay, so of our 300 people, 120 will stay. So to find that as a percentage, what you do is 120 on the total, okay, times by 100 just to get the percentage. Okay. And in total, that was 40%. Okay, so a bit of work in there, but A is correct. 40% will stay in the same activity for the next night. Okay, B, 40% of those who dance on the first night do not dance on the second night. Okay, so we had 100 people dancing on the first night. Okay, and those who do not, I should actually highlight that, do not dance on the second night. We actually don't even need the initial amount. What we can do is we look in the transition matrix. Okay, and we can see that 30% will go to lawn bowls and 10% will go to bingo. Okay, so in total, 40% of those won't dance. Okay, for that second night. So B is correct. Okay, C, 40% of those who were at bingo on the second night were playing lawn bowls the night before. All right, so if we look on the second night, the number of people who were playing lawn bowls, if we just move across, okay, it was 100 people. All right. What we want to know is whether 40% of those people who were at bingo on the second night were playing lawn bowls the night before. Okay, so the people who were playing lawn bowls the night before, again, was 100. All right, so that's this column. So the number of, or the percentage of people going from lawn bowls to bingo, okay, is this 40%. Okay, so essentially what you're doing is this 100 times 40, okay, will equal like 40 people in total, or 40%. Will equal 40 people. Okay, and what this question's saying is that of the people who are doing bingo on the second night, which is 100, okay, 40% will come from lawn bowls. Okay, so 40% of 100, okay, is 40 people. So that matches up. All right, so that's correct. All right, sorry if I explained that really bad, but yep, that's that one. Just go back if you need that one again. D, 40% of those who played lawn bowls on the first night, okay, will play bingo on the second night. Okay, so what I might quickly do is I'll just rub out all the stuff in the transition matrix. So what we're doing is we're looking at those who did lawn bowls on that first night, and 40% of those will go to bingo. So we've got that transition there. Okay, so that one's correct as well. Okay, E, 40% of the holiday makers will be dancing on the second night. Okay, if we look at the second night, that transition matrix over in the top right, we've got 130 people who are dancing. Okay, and what we've got to do is just work out whether that'll equal 40% of the total people. So we've still got 300 people in the holiday resort. Okay, so we've got to work out whether that's 40%. Okay, so 130 on 300 times 100. All right, and that'll equal 43.3 repeat percentage. Okay, so yeah, we eliminate all the other ones, but E's the incorrect answer. But yeah, a question like that, even if like you do everything else and just give you heaps of time to do that one, okay, don't waste heaps of time on that. Like all of these multiple choice questions are worth the same. Okay, so if it's just confusing, like skip that, okay, and go back to it and give yourself like a bit of time to do that one as well. Okay, I definitely find that the not trues and the statement questions are the hardest, or just time consuming. Okay, the following information should be used to answer questions 15 and 16. Okay, the graph below shows the one-step dominances that exist between 5 backyard chooks. Okay, Mildred, Audrey, Rose, Norma, and Portia. Okay, for example, Mildred has a one-step dominance over Audrey, okay, as the arrow on the graph indicates. Okay, according to the graph, the number of chooks that Audrey has a 2-step dominance over is. Okay, so there's a couple ways of doing this, but If we look at Audrey, okay, to find the two-step dominance, that just pretty much means that Audrey beats someone, okay, and they go on to beat someone else. Okay, so if we look at Audrey, Audrey has a one-step dominance over Portia, okay, and over Rose. Okay, I don't think there's anyone else. No, and so the two-step dominance means that of the people Audrey beats, they go on to beat someone else. So if you look at Rose, okay, the only other person that Rose beats is Norma. All right, and if we look at Portia, the only other person that Portia beats, okay, is Rose. All right, so the number of two-step wins that Audrey has, okay, is just that 2. All right, so the answer will be C. Okay, the other way you could have done this, and some people like to do it, but it's time-consuming, okay, is actually make your one-step dominance matrix, okay, with all the chooks. So it doesn't actually matter the order you put it in. I'll go Audrey, Mildred, Rose, Norma, Portia. Okay, Audrey, Mildred, Rose, Portia, Norma. Okay, and this is lost, this is win. Okay, and you just go through each one. So each person can't beat themselves. Oh, sorry, I've realised I've put a letter in the wrong spot. This should be Portia here, and this is Norma. Oh God, I just did it again. That should be Norma. And this should be Portia. Okay, so zeros all down the diagonals, and then you could just fill it in one at a time. So I'm not going to do all of them, but if I look at Audrey, Audrey will lose to Mildred. Okay, that's this line here. Okay, Audrey to Rose, that's that red line we've already done, is a win. Okay, Audrey to Norma. Okay, that's this line. Okay, Audrey loses to Norma. Okay, and Audrey to Portia is a win. Okay, and what you do is you just go through each of those ones, and to find the number of two-step wins, once you've done it, is you just square it, okay, and add up the rows for Audrey, and that'll give you the total number of two-step wins. Okay, definitely longer, but another way to do it. Okay, question 16. The graph above does not show which chook is more dominant, okay, between Mildred and Norma. If Mildred has a one-step dominance over Norma, and considering both one-step and two-step dominance, the ranking would be. So pretty much this question, guys, is asking for the total dominance, okay, and just the ranking. So what you're going to do is add the one-step, okay, and the two-step dominance matrix to find that order of the ranking. So what I might do is I'll actually continue with my dominance matrix over here. This is my dominance one. Okay, I'll rub out, because there's stuff going on everywhere up here. And I'll just fill in each of the elements. So Mildred, okay, skip ahead if you don't want to watch this. Mildred beats Audrey, Mildred beats Rose, Mildred loses. Mildred and Norma don't play, so that's just a 0. Mildred beats Portia. Okay, Rose loses to Audrey, Rose loses to Mildred, Rose to Norma is a win, and Rose to Portia is a loss. Okay, Norma to Audrey is a win. Norma to Mildred, they don't play. Norma to Rose is a loss. Norma to Portia, okay, is a win. Portia to Audrey is a loss. Portia to Mildred is a loss. Portia to Rose is a win. And Portia to Norma is a loss. Okay, so what I'm going to do is I'll quickly just square that in my calculator now to get the d squared matrix. All right, so I'll show you what that is. Okay, d squared equals, give myself a room. Okay, definitely don't do all this working in your SAC or exam, but I'm just doing it to show you what those numbers are. Okay, so this is the number of two-step wins they have over each person. 1 0 0 0 1 0 2 0 1. Yeah, just skip most of this if you want. All right, and again, that's in that same order. So A, M, that's an M, R, N, P. All right, so then in your calculator, you'd add up this matrix with this matrix. Okay, so I'll quickly do that. All right, that'll get you the total number of wins. Again, what you could do is just add up the rows. That's fine. So 0, 2, I'm just showing you. So this is the two added up. 1, 2. Okay, so the number of wins, so 1 and 2 step wins, you just do by adding up the rows. 1, 0, 2, 0, 2, 0, 0. Okay, so if I go back to it, this is the chooks and P. So if I add up just the rows, A had 5 wins, M had, what's that, 7 wins? R had 3, N had 5, P had 2. Okay, I think the answers might have been a bit wrong with the total number of wins, but I think the order's still fine. So if I rank that, okay, the number of wins, or the best chook was Mildred. Oh, I realize I've stuffed up. This is, Audrey's had 4 wins. Can't count. Norma would be the second best. Audrey third, fourth to whoever R is, and 5th. Okay, so we're looking at order. So first Mildred, second Norma. Okay, the only one that's got Mildred and Norma is 1 and 2 is C. Cool. All right, the rest are fine as well. All right, section B. Okay, write down the order of matrix M. I just haven't read the question. That's not what you should do, but that's 2 by 3 matrix. Okay, given that Q is that, find the matrix product R, where R is M times Q. Okay, so just making sure you do it in this order. Do M times Q in your calculator. Okay, and that should give you, it'll give you a 2 by 1. Oops, sorry. Which is 70.6 and 76.7. Okay, where that is Gunnings and Pastors. All right, see, in the context of this question, write down the information that matrix R tells us. So looking at that matrix we just did, what do these numbers actually mean? Okay, so I didn't read the question, but if I go back and look at it, our original matrices, so matrix M, that told us the costs of the products for a control box, plastic piping, connecting at each store. So Gunnings, the control box costed $32.60. Okay, and the control box at Pastors, I should highlight these numbers. The control box at Pastors cost that. Okay, so if we times it by matrix Q there, those numbers essentially is just adding up the rows of each matrix. Okay, so what that tells us, that's the total cost for like the control box, plastic piping, connector, at each hardware store. Okay, so I'll write that. It's like total cost of watering system. You put plumbing, whatever you wanted. At Gunnings. Gunnings and Pastors. Cool. All right, question D. Again, I think this is a question that didn't format really nicely in the first one, so yeah, apologise for that. We've got matrix D, okay, with an unknown value there. The matrix product DM gives us a matrix of order 2 by 3, okay, which gives us the same prices for products B, P, C at Gunnings, okay, but a 10% discount. Okay, that's a really badly worded question, but essentially what it's going to do is reduce all the values in this initial matrix up here, okay, by 10%. All right, find the value of A. Oh, sorry, it's not each of the values, it's only for Gunnings. Is it? Oh no, 10% discount at Pastors. Okay, I'm going too quick. But, so if Gunnings are staying the same, okay, that means, yeah, you times in by 1. Okay, and this 0.9 here is that 10% discount for Pastors. Okay, remember if we're applying discount, those values go down the diagonal, okay, and the rest of the values are zeros. Okay, so the value of A is just 0. All right, and if you wanted to check, you could just multiply those two together and see if you get the 10% discounts as well. All right, question 2. Bruce has 4 hardware stores. Okay, Gunnings, Pastors, Joe's, and Hardware Land. Okay, that he goes to regularly. He has a set route he always travels along to get from one store to the next. Okay, matrix A shows Bruce's route from one store to the next. Okay, what that's saying, pretty much, when there's a 1, that's just telling us that they're going from that store to the next store. Okay, question A. One day Bruce was visiting all 4 hardware stores. Okay, and he started at Hardware Land. Write down the remaining stores he visited. Okay, in the order he visited them. Okay, so if he's at Hardware Land, okay, this is like this store's Hardware Land. The next store he'll go to, okay, is Gunnings. Okay, and then you just keep following that. So he's gone from Hardware Land to Gunnings. Okay, when he's at Gunnings, all right, the next store he's going to go to is Joe's. Okay, and then he'll go from Joe's. Okay, and the next store he'll go to is Pastors. Okay, question B. On a day where Bruce visited all 4 stores, he finishes at Hardware Land. Okay, which store did he start? Okay, so this is pretty much going back the other way. What I might do is I'll have Hardware Land at the end. Okay, and just retrace our steps. Okay, so I'll just remove this. Okay, so it's going backwards. It's pretty much saying he ends up at Hardware Land. Okay, the store he goes from to Hardware Land is this Pastors, because it's like the next store's Hardware Lands. The store before will be Pastors. Okay, remember he's visiting all 4 stores, so then from Pastors, the store he visited before that is Joe's. Okay, and then if we look at the Joe's row, the store he would have come from is Gunnings. Cool, so the answer's Gunnings. All right, you can just cross that out. That was just for our working. All right, question 3. Ashes selling raffle tickets for a bowls club as well as for a local cricket and tennis clubs. Okay, the number of each type of ticket she's able to sell to her friends, her neighbours, and her family is shown in the table below. Okay, let the cost of a ticket, so I'm just reading below the table. Let the cost of a ticket for the bowls club raffle be X, cricket club be Y, and tennis club be Z. Okay, using the information, fill in the 2 missing elements in the matrix equation below. Okay, so if we look at our table, okay, this is essentially one matrix, all right, and this guy's our other information, because that's the total sales. So if we've got this 7, this matches up. All right, the common mistake would be to put 4 in here. Okay, but this is changed the rows, like the position of the rows and columns. So if we look, we've got 7 as our first number there. Okay, the last number we've got is 8, which is this guy. Okay, so the number in between that's 6. Okay, and then the other matrix, this guy, the last number there's the 148. Cool, find the cost of a cricket club raffle ticket using the matrix equation in part A. All right, so this is like simultaneous equations. So if I put this guy as A, this is B, this is C. Okay, what this looks like is A times B equals C. We're trying to find B. All right, so to get rid of A, we use the inverse of it. Okay, remembering to put that out at the front and times that by C. Okay. Okay, and what we get is some ugly numbers. We get a 3x1 matrix. This is 2 point. Okay, because we're dealing with money, I'll go to 2 decimal places. This is 5.28. And this is 2.23. Okay, and what I wanted to know is the cricket club one. So this is bowls, this is cricket, this is tennis. Okay, so therefore, cricket ticket sale or ticket cost is $5.28. Cool. All right, moving on. Question 4. Short answer is so much better. That's just easier. It's good. All right, thanks for watching if you're still watching. For 2012, the 80 members of Ash's Bowls Club had 4 options with regard to renewing their membership. Okay, they could pay online, in cash, by direct debit, or leave the gym, and their member lapses. Okay, the number of members choosing each of these options in 2012 is given by the matrix. Okay, so we've got the matrix there just showing what people are choosing with their payment methods for the gym. Okay, the way in which it was anticipated that members would change their renewal options in subsequent years is given by the transition diagram below. Cool, so we've got that transition diagram. Okay, question A. How many members who paid their 2012 membership with cash are expected to pay online the next year? Okay, so the number of people who paid in cash the year before is 30. Okay, and if we look at the transition diagram, starting at cash, the ones who are going to go to online is this line here. Okay, so 20%. Okay, so 20% of that 30 will go. Okay, which will be 6 people. All right, people. Explain why no arrows in the diagram lead away from L to any other options. Okay, so this is looking at this dot up here in the top right. Okay, when someone essentially has left the gym, they're going to stay left. Like, they're not going to return. Okay, so essentially means once someone leaves the gym, like they won't return. Or, yeah, to any of the options. So, once... Okay, question 4. The transition matrix T represents the transition diagram is given below. If this pattern of renewal were to continue, the number of members opting for a particular option in the nth year could be found by evaluating the state matrix. Okay, so we've just got the recurrence relation to find each year. Okay, so find S of 2013. Okay, so to find S of 2013, what we do is our transition matrix times by the year before, so 2012. Okay, so essentially what we do is this matrix and times it by our S of 2012 up here. All right, so I'll quickly do that. Okay, so what that gets us is a 4x1 matrix, so 34.35, 18, and 9.65. So find the number of members who paid cash, okay, in 2013. Okay, so just labeling this matrix, the number of people who were cash were 18. Cool. All right, in which year does the number of members renewing their membership online first exceed the total number who pay by other methods? All right, so if we look at the number of people who pay by other methods, we've either got cash or, I can't remember D, I think D might have been direct debit or something. Okay, so in total that's 36. That number is bigger than the number of people who pay online. So we've just got to find which year does this online number beat cash and direct debit in total. So we've got the 2013 one now. Okay, you just got to do this one by one. Okay, you then go find 2014. So you do your transition times like 2013. Okay, and just do them one at a time until this number in the top is bigger than these two together. Okay, so I'll quickly do that. All right, and I do get it in 2014. It's about 37 people do online. And if I add the middle two elements, it'll be about 28 or 29 people do cash and direct debit in total. Okay, so it'll be 2014. Okay, find the number of members anticipated to be at the club in the long term. Okay, so in the long term, you're thinking steady state matrix. Okay, so your transition times your initial matrix, which our initial one was 2012. Okay, and we'll just find the number of people who are going to be, or we'll just find that matrix for the moment. Okay, so I did it, after 100, then to the power of 101. And essentially what you get, okay, is you get 0, 0, 0. Okay, and 80 people have left the gym. Okay, so the number of members that are going to be at the gym long term should be 0. Okay, question 5. Really done? This is the last one? Not sure. Okay, there's one particular item used in the building industry that only 4 manufacturers, okay, M1 to 4 produce, and only supply to 4 wholesalers, W1 to 4 with them. The number of these items produced by the various manufacturers and supplied to the various wholesalers during a month is shown in the matrix below. Okay, what is the total number of these items that the wholesaler, so W3, receives this month? Okay, so if we look at this third row, okay, that third wholesaler is receiving 9,000 products from M1, okay, 7,600 from M2, 8,100 from M3, and 7,800 from M4. Okay, so you just add up that total, okay, which I'll do now. Okay, and what that total number will be is 32,500. Okay, matrix P shows the price in dollars that each of the manufacturers, M1 to M4, sells. Okay, these items to the wholesalers for. Okay, so we've got matrix P. Okay, evaluate the matrix product A times P. Okay, so all you got to do is just this matrix A, okay, and times it by P in that order. Okay, so I'll quickly do that. Okay, so that works out to be, oh, I'm not sure why that went crazy. That works out to be a 4x1, 51,620, 57,940, 69,340, and 58,800. Okay, and that'll be for, that'll be the total cost for each warehouse. Warehouse 2, warehouse 3, warehouse 4. All right, from matrix D, explain what the top value represents. Okay, so that's the total cost of, the total amount spent by warehouse 1. All right. Or total amount spent, or total cost for warehouse 1, doesn't matter. Cool. All right, question 6. A local council surveyed voters to determine the political party preferences. Okay, for the Democrats, Republicans, Independents, and no preference. Okay, matrix T contains the percentage of voters who are expected to change their preference from year to year. Okay, so we've got the transition matrix, okay, for each year. Okay, we've also got the initial state matrix, which shows the number of people who prefer each party type in 2014. All right, and then we've got matrix S1 shows the number of voters who prefer each party type in 2015. Okay, write the missing values from S1, D, E, and F in the boxes provided. Okay, so to find those values, what you do is this matrix, okay, and times by this matrix, and that'll get you the 2015 value. So I'll quickly do that. Cool, so I've got those values. D is 337, E is 109, K and F is 94. Write down a calculation that shows that 360 voters were expected to prefer Democrats in 2015. Okay, so what this is pretty much saying is that 360 people go to Democrats in the next year. Okay, and just show the calculation. So if you look at the year before, okay, which we've got is 2014 up here. Okay, 320 people will prefer Democrats. Okay, and then if we look at the transition matrix, okay, the percentage who prefer Democrats and will stay in Democrats is this 70%, or 70% of them. Okay, so what you do is this 320 times 0.7. Okay, and then get them from each party. So the Republicans had 420 people. All right, and the percentage that will go to the Democrats, okay, is the 20%. Okay, the Independents were 80 people. Okay, and that percentage, you're just following along the row. Okay, it's 25%. Plus, might run out of room. But no preference was 80. I'll just write it below. Okay, and then that percentage to the Democrats is 40% of those. Cool, so that's the calculation. And if you wanted, you could just do that in your calculator and just make sure it adds to 360 as well. But yeah, that's your answer. Okay, question 6 continued. Consider the number of votes who had no preference in 2014. How many of those voters were expected to continue to have no preference in 2015? Okay, so if we look at the no preference in 2014, okay, that was 80 people. How many of those were expected to continue to have no preference? Okay, so we look at the percentage. Okay, the ones going from no preference to no preference is 15%. Okay, so you just do the 80 times 0.15. Okay, which I'll quickly do. Okay, so that's 12 people. All right, consider the fact that 360 voters preferred Democrats in 2015. What percentage of these voters had also preferred the Democrats in 2014? Okay, round your answer to correct to the nearest whole number. Okay, so this is like one of those questions I was like, if you ever see the percentage of these voters sort of thing, it just means what percentage will contribute. So we know that 360 voters will be in the Democrats the next year. What it wants to know, as a percentage, how many come from the Democrats the year before? Okay, so if we look at the Democrats the year before in 2014, okay, we see that there's 320 people. Yep, 320 people the year before. Okay, and the ones in 2015 that will stay at the Democrats, so again, looking at our transition diagram, okay, is that 70%. Okay, so what this calculation is showing is, or pretty much saying, is of the 360 in total, how many came from the Democrats the year before? Okay, so you just do this calculation times by 100 to get the percentage. 320 times 0.7. Okay, so that equals 62 point. And it says to the nearest round to the nearest whole number, so it's 62%. Cool. All right. Surely we're nearly done. Oh, 2 questions. Feel for you guys. All right. Question 6 continued. So the council increased the number of voters surveyed. Okay, matrix R 2016. Okay, shows the number of voters for each party type. Okay, I'm just skim reading here. Essentially, we've got 2 recurrent solutions, okay, which tell us how to get 2017 and 2018 number of voters. Okay, we've been given transition matrix. Okay, and we're also got this addition as well. Okay, so just interpreting this B, we're adding 80 Democrats, 80 Republicans, 40 independents. Okay, and 40 less people are not voting each year or have no preference. Right, so I'll rub that out as well. Okay. The element in the 4th row of matrix B is minus 40. Explain this number in the context of selecting voters who'll be surveyed in 2017 and 18. Okay. I actually haven't done this question. I've answered it before. It was a fluke. 40 people less each year will have no preference. Preference. So 40 people less each year will have no preference. I think, just make sure I've explained that right. The element in the 4th row of matrix B is minus 40. Explain this number in the context of selecting voters to be surveyed in 2017 and 18. Yeah, I think that's pretty... 40 people less will have no preference. Yeah, it's fine. Okay, determine the number of voters surveyed. Round to the nearest whole number who are expected to have no preference in 2018. All right. So what we've got to do is it's a bit tedious, but we've got 2016. Okay, we're going to have to use the recurrence relation to find 2017. Okay, and then find 2018. So we'll just do that to start with. So I'll quickly do that. All right, and sorry, just to show you that working. So what I've got to do is find 2017, okay, which the transition times 2016, okay, plus our B matrix. Okay, and then to find 2018, I'll use T times whatever this answer is, okay, and add B. All right, so I'll quickly do that. Okay, so what I've got is 2018. It's a 4x4 matrix. I've got 5, 5, 5, 1, 8, 407, 0.25, 187, 0.73, 79.85. Okay, I've just rounded a couple of those numbers. All right, but the question, determine the number of voters surveyed, round to the nearest whole number who are expected to have no preference. Okay, so the number that have no preference at this, yeah, and I think that's that. Round to the nearest whole number who are expected to have no preference in 2018. Yeah, so I was just overthinking this. But yeah. Okay, so I've said with, when you got decimals, I'd suggest rounding down to 79 people. I'm actually not sure of the answers, but yeah, 0.85, you can't have 0.85 people. So I'd still go with 79 people, but yeah, I'm not sure on those answers if that rounds up or not. Yeah, that's the answer. All right, last question. Question 7. Okay, so we've got 4 players who are going to compete in a round-robin chess championship. Okay, arrows indicate who's beaten who. Okay, name the players who have 2 one-step dominances. All right, so it's just looking at each player. If I start with A, okay, A has 2 one-step dominances. Okay, so Aaron. And the other player is C. C is the other one with 2 one-step dominances. Okay, so those players are Aaron and Camille. Okay, over which player does Camille have both a 1-step and a 2-step dominance? Okay, so if we look back at the blue arrows, okay, Camille has a 1-step dominance over, I'll just use green, over, Daniel. Okay, and Camille has a 1-step dominance over Beatrice. Okay, so it's pretty much asking which player does Camille have both a 1 and a 2-step dominance over. Okay, so looking at the arrows, okay, the one that works, and I'll rub out the ones that I've done. If we go from Camille, I'll do blue again. Actually, yeah, no. If we go from Camille to Beatrice, okay, Beatrice then goes on, sorry, it's rough, beats Daniel. Okay, so that means Camille will have both a 1-step and a 2-step dominance over Daniel. Okay. All right. In determining the final order of dominance, number of one-step, two-step dominants are added together. Show the calculations for both one-step and two-step dominants, and hence list the players in order from first to fourth. Okay, so it's just time-consuming, not hard, but we've got to pretty much find the total dominance. So I'll just give ourselves some room. Total dominance, which is the one-step plus the two-step ones. Okay, so what we've got to do is we've got to make our one-step dominance one first. Okay, so I'm going to have A, B, C, and D. A, B, C, and D. Okay, and each player can't beat themselves. So zero's down them. Okay, so win, loss. Okay, so the rows, when we add up the rows, that'll be their wins. So we're going to look at just this first one. So Aaron... Okay, so what we're doing is we're looking at I'll just rub all this stuff out. Looking at that transition, that dominance diagram. Okay, Aaron beats Beatrice. Okay, that's that arrow, so that's a 1. And it only beats them once. Okay, Aaron beats Camille. Aaron loses to Daniel. Okay, Beatrice loses to Aaron. Beatrice loses to Camille. Beatrice beats Daniel. Camille. Yeah, just skip ahead if you don't want this. Camille loses to Aaron. Camille beats Beatrice. Camille beats Daniel. Daniel beats Aaron. Daniel loses to Beatrice. And Daniel loses to Camille. All right, so then to find the two-step ones, we'd square that guy, so I'll quickly do that. All right, so what that becomes, the D squared matrix. All right, D squared. Okay, that equals 0, 1, 0, 2, 1, 0, 0, 0, 1, 0, 0, 1, 0, 1, 1, 0. Okay, so show the calculations and hence list the players in order from first to fourth. So I'll just do it below. We're doing T equals, we've got D plus D squared. Okay, so what you do is you'd add those two matrices. Okay, so I'll quickly do that, or we can do it in our head. What I'll get, so all I'm doing is adding across the rows for each one. Okay, so I've got 2 wins in the first one, first row for the dominance one, and I've got 3 wins in the first row of the second one, so in total. I really just should do this one step at a time. Sorry, I'll just do dominance plus the D squared. Until I'm rushing. Okay, and what that gives you is this matrix 0, 2, 1, 2, 1, 0, 0, 1, 1, 0, 2, 1, 1, 1, 0. Okay, and if you add up those rows, okay, that'll be their total number of wins. Okay, so Aaron had 5. Beatrice had 2, Camille had 4, and Daniel had 3. Okay, so the question, the key part, list the players in order from first to fourth. So therefore, first is Aaron. Second is Camille. Okay, third is Daniel. And fourth use Beatrice. Cool. All right. Thanks, guys. Hopefully that helped. Sorry again about the formatting of the first one I sent out. Hopefully that should help. But yeah, keep sending through any questions you might have. But yep, still got plenty of time to prep as well. So cheers.